Hi everyone and welcome to this session. In this session, we will discuss about sole-tenant nodes, why it is required, what are its different components, as well as some of its use cases. But before we begin, let us see its one-line definition, which says physical servers that runs VM from single project, which means that the physical server will have the VMs which will be created only from that single project. That is, there is one-to-one banding between the physical server and the project. We can also say that the physical server is reserved for hosting the VMs created by the single project. Now let us move ahead and show in details. Compute engine is one of the service of the GCP. It enables us to create virtual machines on the physical server. The host physical server is shared by multiple VMs. That is, the hardware of the server is used by many projects. What it means is that when we create a virtual machine by using the compute engine, the virtual machines get hosted on any of the physical server present. There is no such rule or there is no such mapping between the virtual machines and the physical server. So we may have a physical server which will have a virtual machine from multiple clients, and such scenarios is known as multi-tenants. In contrast, if we talk about sole-tenant node, in this case, we have a physical compute engine server that is dedicated to hosting only specific projects VM, as we have told you earlier. All VMs created by the customer is hosted on the same sole-tenant node, thereby provides hardware isolations and separation from other projects. Now, one question which may comes to your mind is that why do we need such sole-tenant node? Is there any need to have a separate physical server to host the virtual machine for a specific project? Yes, yes, it can be. It depends upon the security concern, or you can say it depends upon the licensing of the company. If the company is very secure, if it has too much concern about the security, in that case, that company may wish to put all of the VMs on a specific server whose resources will not be or should not be shared by any other VMs. To make the point more clear to you, we can say here that we have here two sections. One has name multi-tenant host and other the sole-tenant node. In the case of multi-tenant host, we can see that we have four VMs which are created by three different customers. So in this case, this physical server has got VMs from the multiple customer. But if we talk about sole-tenant nodes, in this case, we have four VM, but all those four VMs belong to a particular customer. So we have seen how there is a banding between the customer or the project and the physical server. Now let us see what are the different players involved in creating a sole-tenant node. If we wish to create a sole-tenant node, then first of all, we must create a node template. Node template, as the name suggests, it is a type of a blueprint which decides the specifications of the node. It has got primarily two sections. One is the node tab and another one is the affinity, which is optional. The node tab here basically defines what machine type is allowed for this type of node. You can see here we have, as an example, I have put there the node type as N2 and node 80 and 640. N2 here is a machine type, 80 is the number of the vCPUs, and this is the GB or the memory required. Now, once we have created the node template, then the next step is to create a template group. This template you can see here, this template group. So while creating a template group, if you go through the console of GCP, first of all we are required to create a template group, and in the process you will be asked to create a node template. So the node template is injected into the node group. Node group may contains 0 or more nodes depending upon the VMs that meet the criteria of the node template. Now moving ahead, in the third step, we need to create the VM and provision them onto the sole group. Now in the next slide, which has got a bit more details than the earlier one, here you can say that this is the node template and this has got some specifications with it. This specifications tells that on this node only those VMs will come. This is a VM. Only those VMs will come which will have N2 machine type. You cannot have different machine types present on the same node. What I mean is that if we have a node N1 and this node has this node type as a specification, then we can put only those VMs, VM1 and VM2, whose machine type is N2. Fine. We cannot have any other machine type rather than N2. Now, moving to this node group, it says that it can have 0 to more nodes. 0 to more nodes depending upon the number of the virtual machines that we have created. Here I have told you that once we have created the node group and we have created the template, the last phase is to create the VM. And to create the VM, we use the compute engine. And at the time of creating the VM, we add the affinity. We add the affinity details on the compute engine, which will decide on which node it will be get placed. On which node it will be placed. So these are also important steps. You can see that machine type of VM must match the machine type of the node template. Means if you are creating a VM and if you wish to add them in the node group, then that template machine type must match. Other thing is that machine type of the it must match. The second one says, however, the machine size may differ. What does this means? What does this means is that if we have a VM, okay, and suppose that this VM has total of, it has a capacity of 40 vCPUs, okay, and you have a let's make this as a 400. It has a 400 vCPUs. Now you have created 4 machines of this type, of N2 type, having 80 vCPUs. So 18 to 4, yeah, this is 320. So we have occupied 320 vCPUs out of 400. Now the remaining is 80 vCPUs. Fine. And to digest this, we can place here 2 virtual machine of type N2. Type should not differ. Its type should be N2, but it can have a vCPUs of 40 and 40. So this is what it tells. However, the machine size may differ. I think the point is clear to you by now. What is the node template? What is the node group? And how we create the virtual machines and how the virtual machines get associated with a particular node. One thing which we must know is the node type. So let us see what are the different node type which is provided by the sole-tenant node. As you can see over here, We have 1, 2, 3, 4, 5, 6, 7. So 7 different node type are supported by sole node template. Here you can see the first one refers to the machine type, and then we have 40 as the vCPUs, and then we have the GB, which is the memory. We should have a knowledge of this when we are creating a sole-tenant node, because based on our requirement, we may try to tweak these values. Now another interesting stuff is node affinity and anti-affinity. As I have told you earlier, that when we create any VM, when we create the VM, then where on which node it will get placed, that is decided by the node affinity. So here we have some key value type stuffs. Okay, and on the node also we have some key value. Suppose it is key and value is v1. Fine. Then at the time of creating the VM, we say that the node affinity should be v1. In that case, this VM will get placed on this physical server. So the node affinity says, specifying affinity: when you create a VM, you must schedule VMs together on a specific node or nodes in a node group. While opposite to this, we have a anti-affinity. This anti-affinity says, specifying anti-affinity: when you create a VM, you must ensure that creating VMs are not scheduled together on the same node or nodes in the node group. Moving ahead, let us talk about its maintenance policy. While talking about the GCP, we have seen in the compute engine that the compute engine supports the lab migration, which is the default. This is the one of the property of the VMs created by the compute engine, that in the case of update, the VMs get lably migrated from from one physical server to the other physical server without being getting restarted. So the first maintenance policy is that only. It says that lab migrates of VMs, updates available VM migrate to the updated host. So there is no restart. But in the second case, we have a restart in place, and that means that stop the host if the update is available. Now the host is offline during update, and once the update gets completed, the VMs are automatically restart after update. VM maintenance policy should be terminated. VM maintained policy should be terminated. This means that the virtual machines that we have created for adding to a node here, the maintenance policy, under the maintenance policy, the value should be terminate. It should be terminate. Then only we can use restarting policy. The third one is migrate within a node group. In this case, we have one surplus physical machine. We have a surplus physical machine. So suppose that we have A and B, and these two are live one, means they are being used. So we have to create one surplus one. This is an extra physical server, and when this has to be updated, in that case, all the VMs which is present on this get migrated to this. Now once this gets migrated, this will become empty, and now when B has to be updated, all the VMs which are present on this gets migrated to A. So this is how migrate within node policy works. Now let us see some of the use cases where it fits. First is the gaming workload with performance requirement. So if you are interested in having means if you are dealing with a gaming workload, then there we have the sole-tenant nodes. Or you have finance or healthcare workload with security and compliance requirement, window workload with latency requirement, machine learning, data processing, or image rendering that requires GPUs. It is also ideal for high IPS, that is high input on and decreased latency. This is all in this session. So we have learned what is the sole tenants, why it is required, what are the different players, and some of its use cases. In the coming session, we will see its lab.